Sequence and summation notation, part 2. Finding the nth term of a sequence. Okay, so here we, in the last section, learned how to generate each term of a sequence. Here we want to say, okay, is there a way to look at a pattern? Can I figure out the pattern and find an nth term of the sequence? So what they're asking us to find with the nth term of the sequence is a sub n. We want to find that formula. Okay, so we got 1, 3, 5, 7. So we could probably guess the next term would be 9, 11, 13, and so forth. Okay, so we're looking at, and also thinking of what n is equal. N equals 1, n equals 2, n equals 3. How can, if n equals 1, 2, 3, can I get these numbers generated? Okay, so if I look at n equal 1, and I somehow need this to be 1, n equal 2, we need this to be 3, n equal 3, we need this to be 5, n equal 4, n equal 5. Let's just look at a couple of these. This needs to be 7. This needs to be 9. Is there a formula that I can look at generating? Notice that this is plus 1. This is plus 2. This is plus 3. This is plus 4. This is plus 0. Okay, so let me see if we could figure something out here. 1 plus 0 is 1. 2 plus 1 is 3. 3 plus 2 is 5. 4 plus 3 is 7. 5 plus 4 is 9. If we take n and add n minus 1 to it, that's going to generate our numbers. Okay, so let's see if that pans out if n is 6. Okay, so if n is 6, we're going to plug 6 in here. So that's going to be 6 plus 6. That's going to be 12. 12 minus 1 is 11. And notice that is the next odd number. Okay, so I think we got something going on here. In order to get the nth term, we're going to take 2n minus 1. Okay, so let's see how that works out. Okay, so we're going to go into second list, ops. We want to look at the sequence. We think it's 2n minus 1. The variable is x. We're going to start at 1. Let's go out to maybe 6 terms. Let's see if this generates what we think that it should. It generates 1, 3, 5, 9, 11, 13. So we're pretty confident in our formula. Okay, so here we just did this one, but I wanted to just kind of relook at it. Let's say we didn't just do this formula. Let's see how we could establish a pattern. 3 to the first, 3 squared. The next one is 3 cubed. If we put into our calculator 3 to the fourth. Okay, so then 81 would be 3 to the fourth. The next one would be 3 to the fifth. And so all we'd have to do in this one is remember that this gives us alternating signs. N equal 1, I got a negative. N equal 2, we got a positive. N equal 3, we got a negative. So that looks good. And then this would be 3 to the nth. Since these are both to the nth power, we could bring that n out and write it in this way. So that would be the nth term. Let's look at our next examples. Problem 34. Again, find the nth term. So when we're looking at finding the nth term, what we're doing is we're finding that formula that's going to generate this pattern of numbers. Okay, so here we have 3, then we have 0.3. Okay, so let's see, 0.3 would be 3 over 10. That would be 3/10. Then 0.03 would be tenths, hundredths. Then tenths, hundredths, thousandths. And when we try to, again, just look for that pattern and sort of treat this as a puzzle, we can see that 3 to the first, 3 to the 10th, 3 over 100, 3 over 1,000. Okay, so what's going to generate the set of numbers? This would be then 10 to the 0. This would be 10 to the first. This would be 10 squared. This would be 10 cubed. And so I think that we got it. That would be a sub n is equal to 3 over 10. Now, not to the n. Why is it not to the n? Because remember, n starts with 1, and that would be 3/10. Then n goes to 2, and that would be 3 over 100. So this is actually 3 over 10 to the negative 1. Let's look at problem 36. Okay, so we're always, again, we have to remember what values n can be. N can be 1, n can be 2, n can be 3, n can be 4, n can be 5. Okay, so that's the domain of our sequence. What we have to do is figure out if n are these numbers, how can I use that to get these numbers? Okay, so if n is 1, 1 plus 2 is 3. Okay, so up top we might consider n plus 2 up top. If we look at the bottom, let's see, the bottom, if n is 1, 1 plus 3 is 4, 2 plus 3 is 5, so we might consider n plus 3 for the bottom. And that could be a possible an formula. If we check that in our calculator, let's see if we can get our terms generated. Okay, so we're going to go to second list ops. We're going to go to option 5, which is sequence. We think the formula is n plus 2 in the numerator and n plus 3 in the denominator. X was the variable that happened to be used in that expression. We're going to start at 1. Let's go ahead and go to 6. We'll look at the first 6 terms. And we know this one, we're going to have to add math fraction to the end. If we add math fraction, there it is, 3/4, 4/5, 5/6, 6/7, etc. So we know we have a correct formula.